Could you say could you say anything once again?
If you can hear me, because I don't heard it correctly. Is that okay? Yes?
Now not.
No. Because I don't want it to bump into. Okay, now?
It depends on the position of your head. If you have head like this, it doesn't work.
Okay. Maybe I will just, take it.
You have also. I think that this microphone.
No, this one's okay. This one's okay.
Okay.
I can work with this. We can wait a little bit.
I can maybe announce that.
If you want, you don't have to, but. Okay, I think we can start. So, okay, something's happening with the connection. Why? I don't know why it's doing what it's doing. Because it's just, disappearing. But it shouldn't be a problem with this. Mom.
Try with half, maybe. Maybe. On the side.
That's working. Zobaczymy, czy będzie, czy nie będzie. No znika, jakby coś gdzieś tam...
To jest w jakim formacie? PDF czy w jakimś innym?
W Kinocie.
A da się to zapisać w PDF? Czy tam są jakieś efekty ciekawe?
No efekty. Ale to jest okej. Chyba jak nie będę ruszać, bo jak ruszam... No jak ruszam, coś takiego. Okay, I think that works. Okay, so my name is Justyna Szydlowska-Samson, and I would like to welcome you to the introduction to Scikit-learn, which will also be a little bit of an introduction to machine learning, as this presentation is tailored to people that have never used it, and that, or maybe it's this one, that does not have any of the experience before with both machine learning and Scikit-learn. So we are going to have a small introduction. Then I will tell you shortly why Python and what is Scikit-learn. I think it's still happening. Okay. And shortly, what is exactly machine learning, and we'll have a small tutorial. If it's still disappearing very often, then I think we have to switch to, yeah. Okay, so firstly, while we wait for some help, I will introduce myself. I am a research assistant at University of Szczecin in Institute of Management. And my research focus is machine learning in business application and methods of teaching programming, which also lately involves machine learning and the use of machine learning in that and the consequences of students using, for example, ChatGPT. So, why Python? First and foremost, I think it is easy to learn as compared to other programming languages. It is quite powerful and it is free. So there are these three most important reasons, I think, why Python is worthy to learn and worthy to use. It's used quite widely, not only in commercial purposes, in companies, in the inside automation, or in education, or in scientific. In science, so in different, for example, during writing a paper or creating some data sets, or maybe just everything that we need to prepare for our paper. So it's still flashing? No, because it's sometimes is, sometimes isn't. So, Scikit-learn is a free and open source machine learning library for Python. It is built on NumPy, SciPy, and Matplotlib. You can see it in their functions, and it is, as far as Python libraries goes, very well documented. It has a lot of very nice tutorials, and even for someone that does not have any previous experience in machine learning, their documentation also involves the user guide, which also explains shortly, for example, the algorithms. So, what exactly is machine learning? So, here we have a small description, but of course, what is it, how it's looking, and what it can do, and what we even name machine learning is quite rapidly changing as what we can call an artificial intelligence. But shortly, machine learning is just a way for a computer to imitate our human learning abilities to gradually improve its, for example, accuracy in predictions. So it is widely used in business. So we know Google, Netflix, and other such websites and different huge corporations are using it. Any AI needs machine learning. So now I think we can ask who does not use it. It is also important to know that nowadays even government institutions are more and more keen to use machine learning. And also now we are having more and more, for example, large language models that are distributed by some non-profit organization, also sometimes connected to the government. So we have few types of machine learning. The most basic ones are supervised and unsupervised, which we are going to look closely today. But we also have self-supervised, semi-supervised, and reinforced learning. So, supervised machine learning is when we have a labeled data set and the machine, let's call it, or model, is learning for this labeled data set. So, supervised machine learning algorithms are regression and classification algorithms, from the basic ones to more complicated ones, neural network and random forest algorithms, which also can be either regression or classification based. I will show you an example of tree algorithm, and we will be basing our tutorial on a regression. And then we have unsupervised machine learning, which is just machine trying to find the pattern by itself. So we don't have the exact labels. We just are giving the data set to a model, and the model is trying to figure out what's happening here. And the example is usually some kind of a clustering algorithm, like k-means, spectral or hierarchical clustering. So, to help you understand a little bit more, here is an example of, for example, someone trying to buy clothes from a website, and with their purchase history and machine learning model, we can learn and hopefully predict correctly which clothes this person is going to be interested in. So here we have two groups of clothes. Of course, this is only a very small example, and most machine learning models are much bigger. Here we know that the clothes on the right are the clothes that were bought, but the clothes on the left were, for example, viewed or maybe recommended, but were discharged or just they weren't bought by it. So we can present it in some kind of a chart where we found two different features. Of course, there's a lot of more features, but for this example, we see two. We can scale it on a comfort and on a color. So, from comfort from low to high and color from bright to dark. And we can see that the green circle show us the clothes that were bought and were chosen, and in the red that weren't. So now, when we have another cloth and we are wondering if this person is going to buy it, we can try to put it here on the chart, more or less. And what do you think? Is this cloth has any bigger probability of being bought, or maybe it's not going to be liked by this person?
I think it will be liked by that person.
And why do we think this?
It has bright colors.
Yes, so when we place our clothes on this chart, we can see that on the chart is close to the other things that were bought, so the things that were liked. Because of that, we can predict that it's going to be bought. But what about this one? If we put it here, it's in the middle. So here we would have, for example, if you imagine that this is your friend and you know what your friend likes, and if you want to buy it, you, for example, have to buy, for example, I don't know, a gift. You need to think if this is a right thing for this person. So we are going to say to this, yes, this is going to be probably liked. And why do you think it is? It's the proximity. You see? There is much more clothes that she chose than the one that she didn't, which is why we can say that probably she'll like it. But like every prediction, that's just some kind of a probability. So this is an algorithm that's called k-nearest neighbors, and what is actually the name suggested, it's just looking at the nearest neighbors, and based on that it is deciding if it's more into one or in the second label. So as I said, we are going to concentrate more on supervised machine learning. And we are going to look at regression and classification. Regression is when we want to predict something that has a continuous numerical value. So, for example, if we want to predict something like a temperature, okay, if we or maybe a price of something. If we can calculate it in continuous value, then we can use regression for it. For classification, it's a little bit more complicated because we want to predict a category. So, for example, if we want to predict, we are, for example, programming some kind of an application for mail, and we wanted to filter out the spam. So it can be regression because something can be like half of a spam mail. We need to categorize it if it's either a spam mail or it's not. Classification is also algorithm that needs to have created labels. And that's why, because I wanted to give you an example that requires minimal effort and minimal knowledge from you in Python. I have chosen the regression because we don't have to create any labels, we don't have to do a lot with a list. We are going to use just Scikit-learn, and we are going to use pandas, which you probably already have had some experience after the previous tutorial. But first, we need to know where to get our data. Because if you want to create our model, we need to have some kind of a data set. And it can be just a 5x5 table. It needs to be quite a lot of data. The more we have, the better accuracy should be. But We'll also talk about their accuracy a little bit later. So we can find some dataset in Google dataset search. We can use Kaggle. We have also government sites, like for example data.gov, which is the United States one, and also a Polish one. I would like you now to find your own dataset. You can do it in pairs if you want, you can do it alone. I will give you some time. Find something that can be used for regression. So, for example, price, temperature, something that you are going to use numerical values, continuous numerical values. So maybe I will show you the Kaggle website. It's going to be maybe easier for you here. You have the data sets and you can write whatever you're interested in. But also here you have some future data sets. You can just look it up. Here the usability score is something you can have in mind, but it doesn't have to be a 10 to be a good data set. What we are interested in is description. So what kind of information we are going to have. Also, for us, it's interesting how many rows, which means how many data we have. We don't want to use a small data set, not only because of the accuracy of the model, but also because we are going to delete some of the rows that have null values in the future that we are going to choose. So usually it's still going to be cut short. But if you see there's not a lot of null values and it's looking quite alright, then even a smaller data set is going to be good enough. It is also good to understand more or less what these numbers means. So what 14 in the anxiety level means, and self-esteem, mental health, depression, headache. So there should be a here description, but we are not going to go deeply into how to analyze the results, or maybe we'll see if we have some time. So, for example, this kind of data set looks okay. So everyone has a data set? Yes? And do you have any question? No? No? Okay, perfect. So, now I will show you small tutorial, but first, just to jog your memory if you didn't attend maybe previous tutorial, we are also going to be using pandas, and we are going to be using it for the data frames to store our data set. Okay, so in the schedule, you should have the GitHub link. I will double check. Yeah. You should have it here. And there you have the data set and the Jupyter notebook file. You can download it, you can just do it by yourself on Python, but you would have to have pandas and scikit-learn installed. So to install pandas, you can use pipe install pandas, and to install scikit-learn, it's just pipe install scikit-learn. So let's just look at the homepage of Scikit-learn. As you can see, it's very user-friendly. On the homepage, you can already see the division of the algorithms for classification, regression, and clustering. And here in the supervising learning page, you have many different models. What we are going to use today is decision trees. And decision trees are basically, very shortly saying, is a method of visualizing the decision process, where we have decisions coming out from the previous decisions, which are going to give us our final answer, final decision. So it's very simple, and you can also visualize it after. And this is what we are going to use today. They are still widely used, and if decision tree is not enough, you can also use a random forest, which is like a lot of decision trees used at once. So here also, like I explained, you can find information also on, for example, the clustering with different examples. You can see the example code. You can even see the different output that it can produce. The decision tree is here divided on the for classification and for the regression. Here's the example, one second, of plotting the visual interpretation. So, if we go back to the notebook, we are going firstly to import pandas and import our dataset. So here the map data is just some kind of quite old dataset comparing different features of homes in Melbourne and its prices. So after we imported the data, what we have to do first is clean it a little bit, because we don't want our decision tree to learn on some kind of a null values. We can have null values in our data set for many reasons. I don't know if you ever did any survey or any questionnaire. Not only you can, as the person creating the survey, forget to, for example, mark some question as required, and maybe sometimes there can be just some kind of an error, or maybe the answer wasn't there and someone just didn't want to put it, and you just had to make this question unrequired, but still you want to use the other data you have gathered. So the easiest way, although not always the best, is to drop the missing values. So first, what we are going to use is from the pandas part. We want to see more or less what kind of information we have, and we want to drop, and here it's important, we want to drop rows, not columns, that consists of a null value. So if in a row we have somewhere null value, we are going just to discard it. This is also best to do after we choose our features, because the null value can be a column that we are not going to use. But for us now it doesn't really matter. I wanted to just stop the pandas stuff before we go to the Scikit-learn, so you wouldn't kind of mismatch it and don't know which part is pandas, which part is Scikit-learn. Then we need to find and choose what we want to predict, and based on what kind of features. So we can just print the column names that we have. You should also be able to see the column names, like I showed you, for example, in Kaggle. A lot of data set has README. Here I choose the price as the prediction target. And usually the prediction target is marked as Y, and the features are marked as X. So the prediction target is one column. We want to predict only one thing based on how many features we want to have. The number of features is something usually you have to try and test. Too many is bad, too little is also too bad. We have both overfitting and underfitting. But let's say I chose this 5 features. So I want to see, I want to predict the price of a home based on the number of rooms, the land size, the number of bathrooms, and latitude, longitude, so basically where it's placed. Here, so let me just run this lines. We can use describe method to see more or less what we have. And with this we can start creating our model. So everything is understood for now? Yes? It's okay? Okay, so as I said, we are going to use decision tree, and we are going to use precisely decision tree regressor from Scikit-learn library. You can import it this way. which will import only the decision tree regressor. Okay, we don't want to import the whole library if you are not going to use it completely. So I really recommend to just import exactly the functions that you're going to be using. And let's just look again at the here. Where is it? Here's the guide, and I want to here. So here you can see what kind of information you can put into this function. You can restrict what kind of maximal depth is going to be of the tree. You can add the random state, number of leaf nodes, and all. For now, as I said, because it's just introductory, I don't want to scare you. We'll just do basic tree. You can write this random state equals 0, but you can just leave it blank here. So this is our model, this is our algorithm, and now we need to train it on our data. So we don't want our model to be trained and tested on the same data. I think it's something everyone now knows, but I will ask to make sure, do you know why we don't want to do it? And test on the same data.
This is not looking at new data to test its.
So it's basically not testing then the accuracy of prediction, but the accuracy how it remembered what it got. So if we train and test on the same data, the accuracy score can be very high, which can be misleading, because if we give it the data that we really want the prediction on, because we don't know the answer, it's going to have a much worse score. And the difference can be between like 90% accurate to 40% accurate, so huge. So we can divide it with the train test split algorithm, which is also from Scikit-learn library. It's just basically dividing the data. So here we are providing y and x, so the features and the target, into 4 different subsets. So features for training, feature for testing, and target for training and target for testing. So you may think, okay, I need features for training and feature for testing, but I know I need the target information, so I want to know what kind of prices my training features had, Yes, the homes that I have in a training set, I want to know what kind of prices they get. But why do I need the testing set for the prediction if I wanted to predict?
Can you repeat the question?
Yeah, so because we have features, and with the features, so for example, the number of rooms, number of bedrooms, we can predict the price. And we have a training set with both information on the features, so rooms and bedrooms, and the prices it got, because we want to train our model on. We have the testing features. So we have the number of bedrooms and latitude, longitude in combination, the model I've never seen before. By why we also need the information on the prices for them if we want our model to predict the prices.
Because the model should make a relation between the features and the value that's being predicted.
Yeah, we need to have the, we want to see how well it's done, but in real life. So we can't really score our model if we don't know what really happened. Yes? So if we just make a prediction, but we don't know what kind of price it really had, we can't really say if the prediction was good or bad. So this is why we need to have both training and testing set for both features and for the target, for the prediction. Okay? So, do you have any question?
So
No?
basically cross-validation.
Yeah, basically cross-validation. So, here the train test split is, I don't remember, I think it's dividing into 80% for training and 20 for testing. I'm not sure, I would have to look at the Scikit-learn website, but here with the test size parameter you can change it. So because my test size is 0.3, this means that for testing I want to have the 30% of my dataset, and the 70% is going to be used for training. Okay, so as we've done this, we can run this code, hopefully everything works. And now we can train our model using a fit function. We are giving it the features, training features, and the training prediction. And with that we can then use our model to predict the prices based on our testing features. So, if you want, we can also print it, but it's not going to look very nice. Yeah. So here are the prices that we have. And now we want to use our y underscore test values and the output of the prediction. So what we have in this prediction variable to score our models. And we are going to use mean absolute error and the regression score. Mean absolute error is just like it says on the name says, it's just a mean absolute error that is between what we predicted and what was really happening, what was the actual price. And here, as we can see, this is our mean value, which is quite high, and our score is 0.54, where 0 is the worst and 1 is the best, so it's like around 50-something%. And just to see how it's going to change, we'll also try the same but with the random forest regressor. And let's see here. As we can see, it didn't really change a lot. You can change the number of estimators and see if something is going to be better, but
It didn't change because I think we were printing the wrong values.
yeah, well, let me see. Yeah, you're right. I didn't see it. Yeah, it's a little bit better, but still it could be even better. It depends on the number of estimation. It can also depend on the where is this? Here. The feature that we choose, because it can just happen that there's no correlation, and all it does is confusing our model. So now I would like you to repeat this step with your dataset. Try to choose around 5 features and see what kind of score it gets. See what's the difference. What kind of score it has with the random forest. What kind of with the decision tree. You can use this Jupyter lab page that I gave you. You just have to add your dataset and change it here. And then, of course, futures and the columns. Do you have any questions? Yeah?
So you talked about train test split.
Yeah.
So sometimes it happens that the split is biased, and due to which we have a very high accuracy when training.
Yeah, it can be. We have different types of doing the cross-validation. We have different types of basically cutting our data into data sets. And then using it in our data. Let me find you one. I don't know if I will find it. It was in a different example here shown very nicely. Just give me a second, I will find it because I don't remember which page, but it has like this very nicely shown graphical interpretation of different type. Maybe I will just find it in.
My question was that can we use something like k-fold?
Yeah. I wanted to show you the k-fold, but I don't remember in which tutorial it was placed. But yeah, with the k-fold, the problem is I think it's a little bit more difficult to use if you don't know Python really well. This is why I didn't show it. And this is only my opinion based on the observation when I tried to show k-fold to my students. But it will give you probably better results. Also, there's more to the different algorithms than just k-fold. Train test split is just the basic one. Also, we need to remember that we have just like some random data sets, which is also a huge problem here. But you're right, maybe just I will see. Up here, it was in the visualization. Yeah. So this kind of graph I was looking at, that when we have our claim to split, it just splits somewhere, and key fault is more doing like this, the splits and faults, and we can even, and it's better to randomize the key fault and even, predict on different run of the key faults. So we have like, I don't know, you are using key faults 100 times and you have 100 different predictions, and then trying to find some kind of mean of this whole prediction. The problem, here is this one. The problem with this is it's quite a fine line between the underfitting, overfitting, and just overall doing too much. It's better, I think, in my opinion, for especially beginners to just feel it out a little bit, see what's happening, how it's doing, and how is the score changing, how is the error changing, and yeah, just try it. You can also try the shuffle split. I think it's a little bit maybe better than train to split, and it's also quite easy to use in the Scikit-learn documentation. You have an example. You can also try key fault, but as I said, the key fault is a little bit more complicated.
Thank you.
So, did you manage to do the script on different dataset?
Yes.
Yes, and how was it? What's your here the mean absolute error and the score?
For random forest or
So let's just say the score for both decision tree and the forest.
okay, so the first one in cell number 15 is for forest.
No, if for
tree.
for
Okay, so for tree I got for MAE, I don't know what it is.
mean absolute error.
Okay, 33.87.
But what is it? What was your target?
I got mobile addiction dataset, and I wanted to measure depression score based on age, income, social media usage hours, and sleep hours. And yeah,
So the score differed around 40 something points, yes?
yeah, 34, yeah. 33.
And what was the lowest and the highest?
I don't know how to get it from the from the script. I mean, I don't really understand here the result of MAE.
But here in the scribe, what kind of information you had
Hold on.
about the values?
So mean, that's what I should be looking at. Mean is 41.46 for age, or for.
Okay, so here I know. It's,
but I should be looking for.
It's better here because there you have information on the answers, but you don't know the score. If there's some kind of readme or something, maybe information. Okay, but anyway, about the score, what was the score?
So I just notebook tab, and this R2 score, right? Minus 1.006.
Okay, that's not good.
Not good.
No, it's okay.
That's both for tree and forest, but no. I'm just trying out.
Anyone else? Okay, we have like around 20 minutes left. If you have any questions, you can ask me. I can come to you and look at what you are doing, or maybe try to help you. If not, I would like to thank you all for participating. I hope it show you at least that Scikit-learn is not to be feared. It's a library that tackles quite interesting but also hard part of programming. So machine learning is usually obscure for most people, but I really recommend you to try and to have fun with it. And always try to look both at the information that we have about the functions and models and all, but also in the user guide where you have more of a theory approach. And if you have any feedback for me, what do you think I should have talked about, or maybe what would you have changed, or maybe what you liked. I would like to also to hear it from you. If you have a second, either now or maybe during coffee break. So yeah, thank you so much.